Welcome to Green Builder Media's ReVISION House here in Scottsdale, Arizona. I'm Steve Easley. Well, I spent the better part of today going and taking some infrared images of my building envelope here. And to set this up, basically what I did was I took a picture of the area that I was going to take a thermographic image of. So this is the actual picture of what we're looking at. This is the actual thermographic image. So that we're all on the same page, when you're looking at thermographic images, the brightest colors are the warmest colors, or the greatest areas of heat gain. The darker colors, like the blue areas, are the cooler colors. And so when you look at this particular picture and thermographic image, I'm looking from the living area into the kitchen area. And this is the north wall of the house, so we're seeing the far end of the sliding glass door and the kitchen windows, and then of course this looks out onto the backyard and to the lake. You can see here that we've got a compound sloping ceiling. There's a beam across here, and this was added onto at one time, is why you got two different slopes in the ceiling. But you can see there's quite a bit of missing insulation here. As well as quite a bit of heat gain around the metal windows and doors, metal frames, and then of course some heat gain around the headers. Now we're going to be putting in exterior insulation, probably 1.5 inches to 2 inches on the exterior to help reduce that thermal ridging. Now we're looking the other direction. We're looking from the kitchen into the family area. This is the other side of the sliding glass door. You notice the dark blue area that we have up there is it's actually register and cool air is coming out of the ductwork. You'll also notice that there's quite a bit of missing insulation here on this side of this cathedral ceiling as well. Quite a bit of heat gain at the header area above the sliding glass door, as well as the metal frames are conducting quite a bit of heat as well. Now we'll go to the other side, and now we're looking on the south side of this room. This wall here is facing the south, and what we're looking at is the entryway. Here's the entry door, and then the dining area. And as you can see, that this area is even worse than the other side. I mean, I have to say that this whole building envelope is a lot worse than I thought it was going to be. But in any event, quite a bit of missing insulation there, as well as a fair amount of air infiltration as well. Now, this is the master bedroom, and it may be confusing a little bit because you look at this square over here on the infrared image and you look at this artwork, you may think you're looking at the artwork, but the reality is this infrared image was taken long after this artwork was taken down. So what you're actually seeing here in the master bedroom, which is the east wall of the house, is actually missing insulation. Now let's go into the master bathroom. Again, this is on the east wall. And as you can see here, this is the mirror and the band-aiding tub area. You can also note that on the other side, there's quite a bit of missing insulation in this bathroom area as well. Now let's go upstairs and take a look at the upstairs hallway. Now this is in the center of the house. You can see here that we've got a register here. And what I want you to pay close attention to, if you look at this temperature at the top here, you can see that it's registering 76 degrees. Well, ideally, we want that air temperature coming out of that register to be somewhere in the 50s, certainly no more than 60 degrees. But the reason that's so hot coming out of there is because it's a little later in the day. This roof has got 1.25 inches or so of concrete tile on top, so that just soaks up that heat all day long and then radiates that into the attic. And that ductwork's probably only got about 2 inches of insulation on it, so there's quite a bit of re-radiated heat into that attic that's being soaked up by that ductwork, and of course cooling the discharge temperature, or heating up the discharge temperature out of that register. Also, you notice over here that there's quite a bit of heat coming down this wall. So for whatever reason, maybe because of duct leakage in my house or whatever, this is under a bit of a negative pressure, and so it's drawing that heated air from the attic down inside that, and that's an interior wall there actually. It's a bedroom wall. And then you also notice that on the far end there, the hallway, there's an attic access hatch that is non-insulated as well. So in any event, again, more missing insulation in the attic. Now let's take a look at the south wall of the upstairs, and this is where there's a back bedroom. And we're on the right-hand side with this image, and you can see there's quite a bit of missing insulation up in the attic. There's missing insulation in the walls, and maybe even some negative pressure there pulling some of that heat down inside the walls as well. Now let's go to the other side of that bedroom, and this wall right here where the closet's at, that's actually the east wall of the house, and of course this is the south wall and back behind the bed here, and you can see that we've got missing insulation on both sides. So that's a little bit problematic. Now let's go to this loft area, which is on the north side of the house on the upstairs. Now this is a kind of a goofy space. It's only, there's no doors on it. It's just an open like loft area, and it's only about 8 by 9 or 8 by 10, something like that, kind of a small space. As you can see here, you can look out through the window here, the blind's closed, but if you look on this west wall here and then you look on the north wall, you can see that there's some missing insulation, quite a bit of heat transfer around the header area and so forth. Now let's take a look at the bedroom adjacent to that that's also on the north side. So here you're looking through this window out onto the lake and the golf course, and what you're looking at across the top here and over there adjacent with the image is we've got quite a bit of heat transfer there, quite a bit of heat gain, probably some not so good insulation around those plate lines. That's the sloping edge of the roof, and so in any event, not good. Now let's take a look at what one of our windows look like. This window is actually facing west, and as you can see, there's quite a bit of heat gain around the frame. And then you'll notice that the actual surface temperature of the glass here is about 95 degrees. Well, the amount of energy from the sun that strikes 1 square foot of surface is about 250 BTUs per square foot. So if we look at a typical sliding glass door that's 6 by 7, and to make the math easy, we'll say it's 40 square feet. That's 10,000 BTUs per hour of heat energy from the sun that's striking that glass. Well, a ton of air conditioning system in an air conditioning system is about 12,000 BTUs per hour. So, bottom line is that's a lot of heat gain off that window, and certainly going to make people feel uncomfortable. So we're going to be experimenting with some different types of low heat coatings to to hopefully circumvent some of that re-radiated heat. Bottom line is, all this missing insulation is going to be a down to the studs remodel. I mean, it just doesn't make much sense to try to salvage the drywall when you have this much insulation repair, plus you have to do air sealing. And also, the upstairs, we're going to do quite a bit of repositioning of walls and so forth anyway, so it just doesn't make any sense to try to salvage the drywall. So we're going to take it down to the studs. We'll be air sealing, we'll be insulating properly. We've got to run quite a bit of new wiring and plumbing and so forth anyway. So bottom line is, we're looking forward to exploring all the opportunities that this can afford us in terms of reducing the energy use in this house, increasing the comfort, and most of all, we look forward to sharing this with all of you.